All right, let's get it. Your reviews is cool. Let's keep going. Real quick. Don't matter, I guess. All right. Yo, welcome to the channel. It's your boy, Street Coder Nate, and I'm glad for y'all to have stopped by today. This is the first learn to get these skills together with Python for interviewing. So what we about to do in this first little segment is tap in with learning pretty much like the overall structure of a coding interview. And then after that, I got a coding problem that we're going to go through and actually do like a mock interview. And then subsequent uh episodes we'll do it all over like that again. Probably explain a little bit more of what we're gonna be doing. Maybe if, like this algorithm about to be pretty simple, we could just dive right in and try to understand using the overall concepts of interviews. But um, pretty much after this episode is just gonna be like I'm gonna have some questions already made up. What we're gonna do is uh, have like a little lesson for the questions and then go into the questions, something like that. So without further ado, we're just gonna hop up into this lesson right about now. So as y'all can see, I got this. I'm sharing my screen over here. Let me go ahead and make that one bigger. There we go. Cool. All right. So what I like to do is I like to take people when I teach people. I like to use my iPad. My iPad like my best friend for real. And so I draw out the ideas that I see in my mind because Python is like a scripting language, so you can't really see the things that you actually code in. It's abstract. You gotta see it in your brain. So what I like to do is take my iPad and I just draw out what I see in my brain when I'm teaching people. So that's what we're gonna do with this one. All right. So let's take our mind out of Python and out of coding right now, and let's just focus on the overall. What is the purpose of what we're doing right now? And so you know how to code, or you about to learn how to code, and after that, you know that you got to go through some interviews. These interviews are going to be mostly data structures and algorithms, although a lot of companies are modernizing now. And if you are going for a web development position, they will interview you on web development things rather than just like general uh, data structures and algorithms. But let's see. In my eye, burning the fuck out my eye. Okay, let's just turn it down. Oh yeah, I can still see me. Ooh. Okay, cool. But yeah, so um, data structures and algorithms. So that's what we're gonna focus on is some data structures and algorithms on this channel, getting y'all prepared that way with Python. We will tap in on some web development interview prep, but on this series, we just gonna do Python interview prep with some data structures and algorithms. So that's basically the first thing you got to be thinking about when you're going into these interviews. When you're going into these interviews, you got your first interview is typically a behavioral interview, and then your second interview is a technical interview that you're gonna have with an engineer, and he's gonna be sitting down on a computer, and you're on the other computer. They're gonna pull up this website. They got a nice little coding editor in there, and you can pick the language you want to code in. Pick a Python, and after you do that, they give you the question or the problem statement, and then they say code the algorithm for that. And so, what you need to be able to do is be able to understand the problem statement, ask the questions that you need to ask while following some type of structure of an interview so that you can, wow the interviewer by the end of the interview. So what there's a lot of information right there. So let's dissect the whole beginning part of the interview. Now, most interviews aren't going to just jump right into like, here's the question. They got about 5 to 10 minutes at the beginning. Overall interview is about 45 minutes each time. So the the first 45 minutes, honestly, in the first interview, the behavioral interview, that one just a conversation back and forth, and they'll say some technical stuff, and you reply with the answers because you know the answers about the technical stuff. So this one shouldn't be hard. This one is, have you ever coded? Pretty much, like they're just gonna say some stuff that should make sense to you. Probably ask you some things off your resume. Don't lie on your resume. I say fluff your resume. You ain't gotta lie on it though, but definitely add that juice to it and let people know those technical things that were done in the project. But you ain't gotta lie on your resume because they're definitely finna ask you some questions about your resume. So in that behavioral interview. And so honestly, the behavioral interview go well, everything flawless. You go to the next round interview, which is that technical interview, that first one. And so in this technical interview, the first, I say 10 to 15 minutes, they try to have a good little conversation with you. They try to break the ice, tell you about themselves a little bit. They ask you to tell them about yourself and, just break the ice. Then after that, they say, okay, cool. We got this problem that I would love to see you solve. Let's get going. And so now you get going and you go do the problem. Now, in this time, most people are thinking, I need to get my mind right for this problem, for this problem, for this problem. But what they forgetting is that the person on the other side of the computer is a person. And so you want to address this person like like the interviewer is a person. So what I mean by that is people like to be engaged. People like to be interested in random things. So what I tell my students is pay attention to your interviewer. When he's telling you things about himself and he's breaking the ice, and then you're telling him about yourself and y'all breaking the ice, try to connect and really understand them and continue to keep those connections going throughout the interview. Like speak to the interviewer, smile, laugh, like honestly try to make the interviewer your friend. Try to literally break that construct that this is an interview. Break it. Because once you put that construct on yourself, you trying to maneuver an interview that you could easily do. It's really just a homework problem for real, for real. You could easily do these interviews. But what happens is you put this construct of how you think you need to follow an interview on top of the complexity of already solving an algorithm. And that just makes shit 10 times harder. So basically, what you need to do is force yourself to make this whole interview process something lackadaisical. Like make this so informal that you can just walk up to this hoe with a t-shirt on, with a wife beater on, with a hat on, and just code. Because honestly, that's what you can do with these coding interviews. You don't have to wear a shirt and a tie and all that. They say come with a t-shirt, don't come formal. So they already telling you not to come formal. And we be trying to think this shit is a lie and shit. Like I remember the first time they said not to come formal, I still came formal with a tie on. Like these motherfuckers lying. They trying to get my black ass. So I was like, hell nah. But yeah, I end up seeing that everybody who was at the interview literally was just t-shirts, pants, like jeans and shit. And the thing is, when you get to the job, that's how everybody dress. You got to remember this software engineer field was full of nerds, and how the nerds dress with some jeans on, a hoodie, a t-shirt. And so literally that's how these niggas go and interview and stuff. So now That's the culture that you're coming into. So think about that culture as you are interviewing. This is a more relaxed culture so that my brain can really process. Your brain can't process real well under stress. And so when you add in all those constructs on top of thinking about this algorithm that you gotta like create, that's just really gonna add, it's just taking energy from you that you could be using for the algorithm. So break that construct. It's not an interview. This is a conversation between two software engineers about an algorithm that will solve this problem. That's all this is. When you are interviewing, it's just a conversation between two software engineers. I don't care where that other software engineer works at. I don't care where you work at. It's just two conversations between two software engineers. And what you're trying to do is figure out how you can use that person and that person can use you together to figure out how to solve that algorithm. That's all it is. And now this is why I said it's just a homework assignment. Because you think about school, that's all you did in school was here's a problem, here's a problem, here's a problem, create some algorithms for these and solve these problems. And you could have some partners, and sometimes you couldn't have no partners. That's all this shit is you partnering up with someone that you don't know, and they want to see how well can you work with somebody to solve an algorithm. Because guess what? When you get on these jobs, you're going to be working with 6, 7, 8, 9, 10 different people on your team. And they're all software engineers, designers, all yada yada. And they want to know, can you talk to these individuals? Can you ask the questions that you need to be asked? They don't, honestly, in these interviews, they want you to answer the question. They want to see the answer be solved. But they want to see that you're using the techniques of a phenomenal software engineer to solve this problem. And a phenomenal software engineer isn't just one who just knows all everything. That's just not what a phenomenal software engineer is. A phenomenal software engineer knows how to use the tools in his toolkit, his or her toolkit. That's what a phenomenal software engineer is. And when you're at an interview, a toolkit or a tool in your toolkit is the interviewer. I like to think of the interviewer as Google for real, for real. So I like to say that I'm taking on this algorithm. I'm gonna go and break it down, how I break it down, figure parts out, connect dots. And when there's not a dot I can connect, what would I usually do? I would go to Google. Google, how do I do this real quick? All right, bet. Grab that from Google, connect the dot, and continue connecting more dots. So when I'm doing that in the interview, I'm speaking aloud, me connecting the dots that of the algorithm, right? I'm speaking aloud how I'm connecting these dots. And then they can that so me speaking aloud helps them follow my thought process. Because what I have to realize is I have a wild ass thought process. And then I realize as an interviewer, I used to interview. So I realize other people got wild ass thought processes. So it's really hard to follow somebody's thought process if they're not speaking it out. Or, so if it's just action and it's just really hard to follow action. So given using that language tool, because language is another tool in your toolkit, using that language tool, explain what you're thinking, explain what you're connecting and what you're building, and the interviewer will be able to follow along and process that information with you. So when you get to a point that you cannot connect the dot, the interviewer is like, ha, I know what dot you need. So the interviewer is already preparing a hint for you so that you can figure it out. And he or she gives you that hint, and boom, you like, oh, you know what? Bet, thank you. And that's like the hint you need to connect the rest of it. That's how you interview. And the thing is, you might not get it on the first and you need a second hint, but it's the process of speaking it out loud, talking back and forth, the conversation with the interviewer, asking questions, listening to the answer, maybe even inquiring more about the answer. Like all of these things, these humanistic things need to come out when you're interviewing. I know we think about the algorithm is the most important part, and it is getting the answer, but you got to remember getting the answer is the byproduct of following all these techniques to a T. Getting the answer will be so fucking simple once you figure out how to follow all these techniques to a T, which is just be a human and learn how to connect back and forth and transfer information. Because honestly, what's happening is we got this mental faculty called our intuition. And our intuition allows us to pick up energy and vibrations. And so all human beings are is just a bunch of energy vibrating and moving at the speed of light, right? And so our intuition gives us the ability to pick up the different energy and emotions from other people. And we can read those energies and emotions. And the thing is, when you connect with somebody with like happiness and high emotions, there's an exchange of information unspoken that helps you during the conversation and interviews. It helps you during the conversation and anything in life, honestly. So, but most people don't understand the secret. And you understand this secret, you can get anything out of interview because the interviewer is just ready to open up and give all information verbally, through emotions, through head nods, through actions, and you just be aware of all of this and you pay attention, and you'll be able to grab all of these things out the ether and be able to knock your algorithm out ridiculously quick. Test it and do all of the above. So my most important let's say key to success in interviews is be a human. Connect with the human. Know that the interviewer is a human. Unless you're doing an AI system, at that point, shit, you got to come AI. All they know is algorithms. But all right, so that's the most important part. But now, more practically, because that was like theoretical, if you will, but more practically, and I think that's kind of practical too, though. But more practically, more technically, what are these steps? So after the interviewer says, "I got this problem set for you," you say, "Thank you, interviewer. I'm ready to take on this problem set." Like ready for you to read it, whatever. Just conversation. Like don't leave it quiet. Like no quiet conversation back and forth. They want to hear your voice. So you thank the interviewer. Now they go on. They read the prompt to you. Then typically after they read the prompt, they go and they show you some examples. And they write out the examples so that you can have them there to refer back to as you write your algorithm. Now, after they just finish that, the ball is in your court. Usually I say, appreciate you for breaking that down for me, interviewer. Always learn the interviewer name. I write it down right at the beginning so that I could just look down, remember the name real quick, and then always speak the name. So appreciate that, interviewer, the breakdown. And then when I try to do is say, I try to notice some things up in the algorithm. Maybe if I don't understand the algorithm all the way, I still try to pick out some things. And I'd be like, oh, you know what? I noticed that this is maybe an array or vector question. I like these type of questions. They stretch my mind. Yeah, man, I'm ready to dive in, but maybe I got a few questions because I don't understand fully the prompt. So I was wondering if you could break this part down for me and break that part down for me. This is legal. This is saying stuff like this is legal. And they want you to say stuff like this so that they can go on and give you more information. They want to know if you're going to ask for more information. Because guess what? When you on a job and you working for them, nine times out of 10, the people that's interviewing you are your managers. Your managers are coders. So not like 9 times out of 10, they like, Is he gonna ask questions when he's stuck working for me, or is he gonna just be stuck wasting time and money when he could just ask somebody this question and then keep going? And so they literally are looking at these things when you're interviewing. Most people not realizing that they're looking at this. This is what they're looking at. They're looking at, do you got these little other skills to help you get the answer that you can get? They want to make sure that you a dog, basically. Like, you gonna get the answer no matter what. No matter if you gotta shake it out the interviewer, but you're gonna do it in the most skillful and the most efficient way. Cause you like a marksman, like a dope ass marksman that can't be found, like that's what they want. And so the thing is, you ain't even gotta like be a dope coder. You just gotta know how to follow these skills for real, and just practice them a couple times. So all right, so after you thank them and shit, now you ask them to break it down a little bit more, to give you some more information. This is what I'm doing as they give me more information. Honestly, I don't be paying attention when they're giving me more information. I ask for more information and I ask for another example every single time. No matter if I understand the question right away or if I don't. Every single time I ask for more information and for another question or another example. Why? Because this gives me another 2 to about 3 or 4 minutes to think of my algorithm. I don't even be listening to them. It's literally like background noise. I smile and I be literally in my head thinking about what they said, how they broke the stuff down. The first time they explained it, I go back and try to underline some stuff while I was still trying to pay attention, acting like I'm paying attention, but not really. It's like background noise. I'm being dead ass. Like, I do not be understanding what they be saying. But the thing is, my body be picking up the information. So like somehow throughout the conversation, I'm regurgitating what they said when I wasn't paying attention. It's wild. But when you learn how to become aware to the whole surrounding, you can not pay attention to something and still absorb the information while you're paying attention to something else. And this is key in like interviews because they're giving off cues all over the place. And you got to be able to pick those cues up like ASAP and run with them. So after like they're explaining during these extra 2 to 3, 4 minutes. What I'm doing is processing stuff. I'm writing down information out. Like interviewers love when you writing down and they talking. So they're talking and I'm writing. They think I'm writing about what they're talking about. But what I'm actually doing is going back, making sure I got all the pieces from the original statement, looking at the first example that he gave me, going through that in my on my notepad and taking and like, I got it, and figuring me out a quick example or a quick algorithm. So by the end of that second explanation, what I typically do is be like, appreciate you for giving me that second explanation and giving me all that extra info. That really helped me tie together an algorithm. And honestly, I'm ready to move forward and explain my algorithm that I think I have. And the interviewers eat that shit up, y'all. Like, they eat it up. It's just like, man, and they like, oh, he saw that he asked me for some help. I spoke, explained some extra stuff. He connected some dots on the iPad or on the piece of paper, and now he's ready to give me an explanation. Now you talk your explanation through. You say, so I see we got this part and we got this part, and I want to connect this like this, and we might need to loop a few times. But in order to follow this algorithm, I gotta yada yada. And so what I like, you go into these details, but the thing is, you go into these details first on the brute force. You want to give a brute force. You always just want to give the brute force. And hear me say, give the brute force. I don't say write the brute force, give it. So basically, see the algorithm and say figure out the easiest way to do it. 9 times out of 10, the easiest way, the first way that come to your mind is the most inefficient way, is the brute force way. And so you explain that. How do you see that way in your mind? How would you do that in just like humanistic terms? Like if you was to explain how to like follow this process to somebody else, how would you explain it in like human logic? And so that's what you want to do to the interviewers, explain this brute force and human logic. And you say, you know what, interviewer, I automatically caught a brute force algorithm for this problem set. And I'm gonna give it to you real quick. They love it. So now you explain the brute force. I'm gonna do this and do that. I'm gonna loop a few times, yada yada. See, it's brute force, and you explain why it's brute force. It's brute force because of the time complexity, of the space complexity. So now you bring in time, they understand that you are understanding about efficiency when you talk about time and space and memory and stuff like that. So you just bring these, you know, keywords in to the interview. Every single interview needs to talk about time, space, or time complexity and space complexity. You don't bring those two words up, you might as well start praying because you just left it up to chance if you don't get the job. You better drop time complexity and space complexity when you at an interview, both of them. And you say this algorithm will be inefficient because of time complexity, and we're gonna go into how to figure out time complexity during these live streams. But we do that, the time complexity, and talk about the space complexity. Now that you already talked about the brute force, here's what I like to call the hard part. The hard part is going from the brute force, taking all the knowledge that you have, plus the brute force, plus the knowledge that the interviewer gave you, and creating a very efficient algorithm that's within the time and space complexity. I say it's the hardest part because this is the thinking part. This is the part where you're just not taking a quick little algorithm. This is the part where you actually thinking about, should I use a stack or a queue? Should I be using k-means algorithm or k-nearest neighbors? Dynamic programming. This is when you need to start tapping into your arsenal of algorithms to figure out the most efficient way to solve this problem. Now, it's only hard if you haven't practiced the algorithms, right? So what we're gonna do on this challenge is practice a bunch of different algorithms, some of the main ones that these companies go over. And what you will see is that these problem sets are just different variations of the algorithm. And you can apply the algorithm and in a certain way with a for loop with a different variable name, a while loop maybe, another function, maybe dynamic programming, and boom, you got the same type of questions that you can generate, right? And so what we basically gonna do on this channel is get you prepared, understand that you're a human, you talking to a human, get this process down of like doing the interview step by step, talking it through the whole time, making sure you know connect with the interviewer, and then really giving that brute force, figuring out how to snap a brute force so quick out the ether, and then at the same time connect the pieces to get you an efficient algorithm that you then go once you speak the algorithm. So you give the brute force, then you speak aloud how you're connecting the dots to make a efficient algorithm. The reason you need to speak this aloud is so that the interviewer can be following your thought process and can help jump in and help you when they need help or when you need help. Bet. So they're gonna jump in when you need help. And until that moment or after that moment, once you finally talked it all the way through and y'all agree on an algorithm, now you can say, all right, now that we got this algorithm agreed upon, I'm ready to write the code. And if talk the algorithm, if you talk the algorithm through the right way, what you will notice is that all you're gonna do when you're writing the code is translate that code from English to Python. That's all you're gonna do. You're just gonna translate it from English to Python. Because what coding really is just giving instructions. Instructions on how to do simple tasks that the computer know how to do. That's what coding is. And so you can code in English, right? You can give tasks in English, and then you can also translate that English to Chinese, to Spanish, C++, Python. These are just different languages. But those ones are computer languages, and we have human languages. But we figured out how to like intertwine those or connect the languages, have a bridge between the languages. What would you call that? A liaison between the languages, and now we can communicate back and forth. That's what coding is. So what you'll see is if you spoke out an efficient algorithm that the interviewer says, you know what, check off, fucks with it, let's get it. All you gotta do now is take that. Well, I like to do pseudocode, so I write English, and then I also maybe will write a little for loop, but then some English in between. So I'll take the pseudocode and literally just translate it right to Python. And it's simple as that. So that's what we're getting into. So once you don't translated it, what you need to do now is first run the function to make sure that you don't have no compilation errors or no runtime errors. Then you need to, or yeah, well, see, I usually do C++ on top of compilation errors. But then after you make sure it can run efficiently, no errors, then you need to run it with some input, the input that the problem set describes. And you need to go through the input and you need to explain the input, like how each other input is going for the interviewer. So you don't want to give a huge input. You want to give something. I usually do like 3 to 5 items in my input, and then I go through and I show how my algorithm is working the way that it's supposed to work. And if it isn't working, then you'll see it and you can debug it and show it in real time to your interviewer that you know how to debug. And you fix it and you go through the problem again, you try another problem set. Then you want to think outside the box of, like, I usually do two what I call sanity tests. I do 2 sanity tests, which means that like the algorithm does what the problem set say it should do, basically at the bottom line. Then I say I need to think outside the box tests, and these are the tests that like if a dumbass person was going to use my algorithm and they just was going to feed it all types of random input, what type of random input could I think these type of random people or these people would put in my algorithm? And the thing is, I want to be able to catch those random inputs. And so you got to think of those random inputs and then go through your algorithm and make sure that your algorithm can catch those random inputs and whatnot. So that's the testing stage, that's the debugging stage, and you follow this whole process to the end, and your algorithm comes out pristine. I promise you, you got a job anywhere that you ever wanted to get a job at. On my mama, I swear to God. So just these are the steps, and you can just rewatch the video how many times that you need to. But what you see is that it's just a conversation, and then it's following just a procedure that you can easily master by practicing and coming back to the channel each Monday and Wednesday to get this free Python lesson. So without further ado, we're about to tap into this Python lesson and or this first lesson on interview prep with Python. Let's get it. So let me pull up. I'm gonna pull up the gotta pull up LeetCode real quick so I can get the problem from LeetCode. Let's Get it? If you don't know about LeetCode is phenomenal. It got a whole bunch of problems or interview problems that these top tech companies like Google, Facebook, Amazon use, and you can go there and you can practice these problems and prepare for your interviews. So I use LeetCode like all the hell, like all the damn time. Like it's hard. Every interview I had. So I think I'm already signed in. Yep. Okay. So what I like to do, I go to interview, and you can go. Oh no, I go problems or explore. It's been a minute. Problems. It might be explore. Let me see explore. Yep, here we go. Yep, explore. So usually what I'm doing is if I'm on LeetCode, it's probably because I got an interview coming up, and so but I'm trying to get on LeetCode a little bit more, just on some fun shit, just to practice my algorithms, get my mind into a more algorithmic state. So, but yeah, what I usually use LeetCode for is to come here and just prepare for interviews. And so let's see, I interviewed with Google, Facebook, and Microsoft and Amazon before. So through all of these, I had a different account. So this is my new account. I might go through them again so I can practice my mind. But on all of these, what happened was I will say, all right, I got my Google interview. And so you can see it say it got 9 chapters on it. So 85 items in here. So let's click inside of it and let's see what happens. Locked. Okay, it's locked. Hold up. All right, so it's locked because this is my new account and I ain't paid on this one. All right, that makes sense. All right, so what we can do though for this course is understand that when you're going and taking these interviews, you're doing data structures and algorithms. So this come down here and you come down and you see learn. Learn is where you want to be at. You can go up to feature, but feature got some where you got to pay, like the Google interview and stuff like that. Learn, most of these are all just free because you learning new things and you learning things about data structures, algorithms. It's not just specific to like a Google interview. And so let's say we doing Monday, Wednesday, the theme is arrays. What you can come here and do is prepare for the arrays come to play. And what it will do, it'll take you to this page where it'll introduce you to arrays, pretty much tell you, here are all the problems you can use to practice for arrays. And look, we're gonna click into one, an array like this, a DVD box. Let's see. So it's just breaking it down. What is an array? It's giving you the lesson on what is an array, and then bang, it gives you a problem that you can solve for arrays right here. So this is important because then you can solve for this, and then you got like more to like practice. So they give you all the information you need to understand arrays. But what we're gonna do is we're gonna go through these segments and then go through these problems. So we'll go through all of these together and understand arrays. Well, fuck. Hold up. Let me go get my charger. Makes me have technical difficulties. All right. We back. So what we're gonna do is go through these problem sets on this channel. Each Monday and Wednesday, we're gonna go through these problem sets, understand this information, and then hop into the actual problems. And then we're gonna figure out how to do them. But today though, I already got a problem prepared. So we're gonna learn the basic structure of how to like break down a problem and solve it today. So yeah, so I'm trying to figure out where the hell that damn thing at. Let's go. Is it in problems? Maybe. And then did I, oh yeah, you know what? And then I think I filtered the list. Uh, 14-day. That's what I did. I tripping. It's the 14-day algorithm thing challenge. Yep. Where is it? Here we go. Yep. 14-day algorithm. And so what this does is it got 14-day structure. You can follow a 14-day structure. We ain't gonna have to follow the 14-day structure. We're gonna take as long as we need to get through all of these questions. But basically it's algorithm, and they got 18 easy ones, 13 medium ones, and 0 hard ones. And for real, when you're practicing for interviews, you only really need the medium ones. The medium ones is good enough to practice. But now, like if you're doing like coding contests and stuff, and you trying to get your algorithm skills real good, go to them hard ones. And then when you just getting into the algorithms and you need to practice, start with the easy ones. And once you get the skill down, then you go to the medium ones and you start timing yourself and whatnot. So that's how I usually use it. So we're gonna start off with the easy one, and we're gonna do a binary. It's called binary search. So let me introduce you to the problem real quick, and we go, figure it out. All right. So let's hop over here, and basically what it says is, so actually I'm giving this like I'm a real interview. So we already talked, broke the ice and whatnot. Now, all right, the interviewer is basically like this. All right, I have an interview problem for you, and I'm going to read it off to you. Now, your response should be, all right, cool, I'm ready, I'm excited. You bring energy to the interviewer, and you let them know that you're not intimidated. You may be intimidated, but just telling yourself and the interviewer that you are excited will get that energy flowing. So, all right, I'm excited. Let's get it. Bet. So now we on some, the interviewer is going to read this to you. So that's what I'm finna do. Given an array of integers, my bad. Given an array of integer numbers, man, my reading is off. Given an array of integers named nums, which is sorted in ascending order in an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. We're gonna skip this line right now and come back to that later. And then usually what they'll do is go through the example. So they'll show you the input is called nums, and it's an array that looks like this. And the target is 9. And basically the output is 4. So they're showing that the index of 9 is at 4. So if we count 0 or -1 is at 0, 0 is at 1, 3 is at 2, 5 is at 3, and 9 is at 4. So the output is 4. So explanation, 9 exists in nums, and its index is 4. That makes sense. We just figured that out by watching. Nums was this array, and they say does 9 is the target, is 9 and nums. So then example 2, it gives us nums like this, and it says is target number 2 up in that hole. And this prints out -1. And the reason it prints out number -1 is because 2 does not exist in nums, so they return -1. If the number doesn't exist, return a -1 index, which means that the item isn't in the array. So they'll give you some constraints down here, but you ain't really got to worry about the constraints just right now. We'll get to that later. And so I just gave you all that information. I bet you lie, bro. What in the fuck? So that's usually how most people are at that point. And this is why I say, no matter what, even if I understand to a T or I don't understand, I say, can you explain me some more, and I just start picking out just random shit to ask to explain more about. And then, can I get another example? And if I can't pick some random shit out to ask for, I just say, can you give me another example? That at least buys me 2 minutes to go over this question right here. And so what I'm doing when I'm going over this question is, let me make this smaller. What I'm doing once I'm going over this question is that I'm using my iPad. So the interviewer, once again, is talking in the background. And what I'm doing now is using my iPad to figure out this question right in front of me. So that's what we about to do. So we're thinking, let's imagine that the interviewer talking in the background, yada yada, telling us about the question. And my mind is like, I'm smiling, yeah, okay, yep, But I'm like, all right, I'm gonna start taking these notes. I'm gonna break this down. So given an array of integers, num. So I have an array. So basically, I'm thinking I have an array, and the name is nums. Array named nums. So I got an array named nums. Bet. That's the first thing. What's next? Write a function to search target, all right, which is assorted and ascending order. So all numbers are going from, and what I'll just say, like 1 to infinity. So ascending like that. You gotta just take notes on how you understand, like me, 1 to infinity, but I understand that means ascending. Cool. So it says, which is assorted in ascending order in an integer target. So we got an integer. So we got this value called target, and target is an integer. And so what I'll do is be like, you know what? I like how I just did target like that. I'm going to go back up here and say I got nums. And nums is an array of ints. And we got a target. That's an integer. Okay, cool. And what we're going to do with the target? Search target and nums. Okay, so write a function to search target. So bet these are our givens. This is what we are given. Now, here comes the request is to write a function to search target in nums. So if target exists, then return its index, otherwise return -1. So what I want to do is search, or what I want to do is find if target exists in the array called nums. And once again, nums is an array of ascending ints, meaning that it's always going to be something like this. It will never be something like it will never be that. It's always ascending and always going forward. So I can assume that my problem, not even assume, but it's a given that the numbers will always be increasing. So what I'm trying to do is I have a target, and the target, let's say, is 9, and I'm trying to find 9 inside of this list. Cool. I understand the problem set a little more, right? Cool. And they was talking in the background while I was connecting it, and I got most of the part down. Now the thing is, if they finish talking and you ain't got it all the way connected, what you can start doing is you can still say, all right, I'm ready to go. I listen, I got some pieces. What I'm about to do is try to connect some things together and get you a brute force. I'm gonna talk my thought process out. And so most of the time you can go back and you can get your givens. And so what you would do is just go over the givens and whatnot and try to connect the givens together. And then also, once you got your givens, understand your requests. So you got your given and then you got your request. You're gonna understand both of those. Or you gonna take your givens and then you're gonna start understanding the requests. So what are they asking you? And basically you start understanding more of the request by connecting the dots with the givens. So that's what we was doing at this part right here. And now what we can do is move down here and start explaining like a brute force algorithm, start figuring out a brute force algorithm to solve this question. And so I'm thinking, how would I solve this as a human? And what we could do is as a human is we could I'm trying to is that on there? Oh yeah, that's what it is. Okay. All right, what we can do as a human is if you see these, like, what is it, nums equals this. Let me see if I can zoom in a little bit more. Okay, there we go. It's a little better. We got nums equals this array. God damn. And then target equals 9. How would I find target? Well, I could take 9 and I can look at -1. I can say, nope, that don't equal 9. I could look at 0. Nope, that don't equal 9. I can look at 3. Nope, that don't equal 9. I can look at 5. Nope, that don't equal 9. I can look at 9. Yep, that equal 9. And say, okay, this is what's the index of 9? The index is 0, 1, 2, 3, 4. Cool. Index is 4. That's how I do it. That's the target. I will return 4. I can see how that one works. Now, what if it doesn't exist in the array? So we'll go, the target is 2, and we'll go -1, not 2, 0, not 2, 3, not 2, 5, not 2, 9, not 2, 12, not 2. We don't finish the array, and we didn't find 2. We can return -1. Cool. That's how we would do it as a human. So what am I saying as I'm going through this? So as a human, I know we have a list of numbers called num, right? And we also have a target that we are looking for inside of nums. I can check each value inside of nums and compare it to the target and see if they're the same, right? So what we can do is check each value, or let's say starting at the beginning of the list. You hear me saying list? An array is just a list. In Python, they call it list. So an array, list, same thing. All right. So starting at the beginning of the list, actually an array in Python is a little bit more complex than the list, but in these problems, an array is just a list right now. Starting at the beginning of the list, check each value inside the list to see if it is the target, right? Then, oh my God. Nope. Where we at? Oh yeah, here we go. All right, let's see if it's a target. If it is the target, so I'll probably change the color. If it is the target, then return the index where the target is. If it ain't, then simply move on to the next item in the list. Check that item to see. I ain't gonna say that. This step will be rerun the checking algorithm. Cool. So as we have already checked by looking at these two examples, this will work, right? This is a lot of chicken scratch, but that will work. Next time, I'll probably bring out the type pad, but I like to just use my Apple Pencil during interviews. My handwriting worked for me. I try to write more legibly in the future, but yes, you want to do what's most comfortable for you in your interviews. So I just broke it down. This is the brute force. We broke it down how we would do it as a human regular. Like if we were just a regular human, how we could just look at the list and just be like, nope, that's under, that's under, that's under it. There it is right there. But now, you hear me say this is the brute force, not efficient. And now, why isn't it efficient? Well, the reason it isn't efficient is I told y'all we gonna skip that part real quick, but now we're coming back to it. The reason it's not efficient is because it says you must write this algorithm with O log n runtime. And so let's go back and review our runtime right now for this algorithm that we have. We're going to check each item inside of nums. Inside of this list, we're going to check each item. So each time, no matter how long or short the list is, we're going to check each item until we find that item in the list. And that item could be the last item, it could be the first item, it could be the middle item. So on average, amortime time, we have to go the entire list because it's like 1 plus n plus 1 plus 2 plus n or something like that. It's some type of explanation breakdown as to like why the over time our algorithm is going to check the entire list, check each item in the entire list. And so what that means is we are going to be running this algorithm in the length of the list. And if the, let's call the length of the list n, like n equals the length of the list. So we're gonna run this algorithm in time n. So meaning that no matter how big, if the list is 9 numbers, we're gonna run this in, let's say 9 numbers. Like, but however long that takes to run 9 numbers, that's how long it takes. If it's 20 numbers, it runs however long 20 numbers takes. And so what this shows is like a linear type of growth, is like as the numbers, as the input grows, the amount of time that it takes to operate grows, right? In a linear fashion. And so that's a more inefficient time complexity than something that's logarithmic growth. And you kind of got to think about it. Like, think about how, like if you take n and you log it, it's a smaller value, right? So like, let's say n is 10, and then you take log base 10, what is that, like 1, right? Or something like that. That's smaller than 10, right? So now you got like a smaller number. And so what they're saying to us is that we want our algorithm to run in logarithmic in time. So whatever the input is, if the input is 20, we want it to run in log of 20 time. We don't want it to run the whole 20 to find the answer. We want it to find an answer in a lot quicker time space. That's what this is saying. So How are we gonna find that in a quicker time space? Well, this is when you gotta start pulling like tricks out of your ass or paying attention to class. And so let's just think about it if we were human. Like one of the things that the book Cracking the Coding interview taught me was that if when you need to make your algorithm more efficient, what you need to do is go back over the problem set and make sure that you're using all of the givens in the problem set. And so let's think about our algorithm. We're going to check each number. We said we have a list of numbers, or called nums. We have a target starting at the beginning of the list. We're going to check each value. So we talk about the target, we talk about nums. So talk about the target, or talk about nums, we talk about the target. But we don't talk about that it's in ascending order. Like we don't work that within our algorithm at all, like anywhere. So is that an important aspect to like making this algorithm more efficient? Well, I would assume yes, because we ain't using it and they gave it to us. If it's a given, you should be using it. Like if it makes sense to use it in the algorithm, if you haven't been using it yet and you need to make your algorithm more efficient, go back to your givens. Like that's like the main thing right there. Is you probably missed something in the connection. And so that's what we did. We missed something in the connection. We missed that that is our list will always be in ascending order. Remember, we already showed that right here that our list will always be in ascending order. So what can we do about that? A list that's always in ascending order. Let's take a deeper look at this list right here. And this list is, let me reshape it. This list is right here. Yep, there we go. Clean that up a little bit. So in the list, we got 0, 1, 2, 5, and 8. And they're all, this list is in ascending order. And so let's say that my target was 5. Well, if we're looking at this list, we can tell that there's 0, 1, 2, and 5. What we can really do is just what we can do is just really go to the middle of this list. And because we know that this is in ascending order, we know that everything to the left of this middle number, oh shit. Everything to the left of that middle number is less than the middle number. And everything to the right, bro, why you keep doing that? Everything to the right is greater than middle number. Now, how does this realization help us in our algorithm? Well, let's check it out. Our target is 5, right? So with our target being 5, I check this middle number and it's 2. I know that everything to the left of 2 is less than 2. So I don't even want to check anything to the left of 2 anymore because I know my target is 5 and 2 is less than 5. So what I want to be checking is everything to the right of 2. So what I can really do is say, you know what? I don't even want to look at this part no more. And I won't. What I'm going to do is focus my attention on this part now. And so what that does is you'll notice I didn't have to look at 0 or I didn't have to look at 1. I just cut my time pretty much in half. Or I cut my space in half and I cut the amount of time I need to take to look at them and compare in half. Now I only compare 2. wrong number. Or now I'm only comparing 2. Let's see what happens. Let's see what happens next on some Drake shit. So now that I'm only looking at the second half, or now I'm only looking at this half, what I can do is split this in half again. And I can, if it's an even set, I can always just say, look to the left. And so what I'm gonna do is compare, is 5 equal to 5? And they are equal. So then I could just return the index like that. But if they weren't equal, then I just split this and then I have to look at 8. And 8 will just be the only one in the list. Compare, is 8 equal to 5? Nope. So then that was the last thing. Shoot, return -1 because ain't nothing else. And it's like, that's a more efficient algorithm because you'll see each time we cutting it down. And we only used a problem set of 5. But imagine you got a problem set of 20 and you go to the middle and you're at 10 and you look to the left, or you look at the one that's in the middle and it's like, oh, that's less than the target that I'm looking for. You just cut off a whole 10 and all you got left is 10. And then you do it again and now you only have 5 left. So you just really only looked at 2 numbers, but you cut your problem set down 15 numbers just by looking at 2 numbers. You only compared 2 numbers, but you cut your problem set down by like 15 numbers. This is very, very efficient. And so this is what honestly computer science is seeing these little tricks within within the givens that we have to write efficient algorithms. And so we ain't really got no time left. We about to shoot out. We ain't got no time left. What time is it? Oh yeah, we definitely got no time left. All right. So what we gonna end up doing is on the next episode, we're gonna hop right back into this one. Or on Wednesday. Yep, we got this on Wednesday. So on Wednesday, what we're gonna do is pick right back up and write the algorithm for this. Finishing out the process on teaching y'all how to break down algorithms in an interview way. But we got our efficient algorithm right here. We're going to rewrite it in English, then translate that to Python code, run some test cases, bingo, bango. We done ran and got our first episode done. Whew, what a mouthful. But yeah, that's it for this first episode. I'm glad y'all was able to tap in with me. It is on my YouTube live. It's my first time doing my YouTube live, but you also see that I'm streaming on Facebook and Twitter. So shit, y'all could just tap in on any of these channels. It's all connected. We got it coming on Wednesday too, but just go back, check out the lives. This is some good info right here. Great little breakdown. I'll see y'all on the next one. Deuces. Boom, boom. Damn, I gotta learn how to get out of this smooth. Let's see. Okay, we still live. We still live, y'all. We almost done. All right, let's see. Oh shit, I was getting chats. All right, so let me close this out. In stream, I did it. I found it. Command G.